to buy cars that emit low emissions. I mean, low emission cars. So I don't know. Once people bought, for example, turbo diesel cars and very low CO2 emissions, and people are so satisfied because this car is seen as an ecological car, then this person travels to Milan, and this person discovers that this car is a polluting car because it emits particles. So what we need to do is to have common and shared policies. That's what we need to develop. And then what we have to ask our politicians is to be consistent in what they say, in the messages they send, they communicate to people. Hydrogen-fueled, hydrogen-propelled cars, for example. From a sustainable point of view, do these cars have a role? Well, as far as hydrogen-propelled cars, well, if you use the car within your town, emissions are very, very, very low. Particles are emitted, but emissions in general are very low. However, hydrogen is an energy carrier, and so it must be produced. As for GHG emissions, the production of hydrogen for hydrogen-propelled cars, well, it must be produced and with systems that are incredibly polluting. Unless I produce hydrogen, I generate hydrogen by using renewable sources of energy. So we need to really think over the policies that we need to implement. Tariff policies related to urban mobility, well, they may be understandable if I do apply the congestion charge of the pollution charge. Well, this can be done, but this must be done in an intelligent way, in a smart way, and alternatives also must be given, because if the public transport system is not efficient, if you ask citizens to move within towns, but asking them to pay to move within towns, then the politicians, in this way, sort of pull the leg of citizens, and citizens do not appreciate this. Any questions? Thank you very much. 5 minutes.
Good morning, can you hear me? Are you having some problem with the video conference system?
Δεν ξέρω πώς είναι το μικρόφωνο μας.
Non so chi sia che c'è davanti, che ne so. Questo qua. Io non so.
Can you hear me now? No.
Θα κλείσω το μικρόφωνο πάλι. Δείχνει ότι δουλεύει, ναι. Ας την κάμερα δεν πειράζει, τώρα που έτσι δεν έχουμε αρχίσει ακόμα. Αλλά τώρα κοιτάζω, εγώ φαίνομαι. Α, κοίτα, φαινόμαστε. Φαινόμαστε στον προτζέκτορά τους. Και ακούμαστε. Μας λένε good morning NTU University.
Ah vabbè, ma sì, anch'io te lo posso mettere su chiavetta, ora ce ne ho 4 da fare su chiavetta. Effettivamente. Non ci stavano mica prendendo 2 qua davanti. Perché comunque avendolo scoperto ieri pomeriggio ho dovuto fare una rappa di informazioni. Aveva preso questi giuridi. Ah, ok. Ieri avevano problemi di audio. Sì, ma quelli Dobbiamo da connettere. Ma no, non è proprio loro. No.
Vuoi vedere là adesso? No, όχι, όχι. Βλέπεις στο προτζέκτορά τους εδώ που φαίνομαι. Μας στείλανε και Good Morning NTUA University. Αλλά δεν ξέρω πώς θα το έχει δώσει. Όχι, τώρα έχω μπει στο NTUA Students. Ναι, αλλά δεν έχει χρησιμοποιήσει μάθημα. Ναι, αλλά τώρα έχω ανοιχτεί, τώρα μας ακούνε. Ναι, εντάξει, δεν καταλαβαίνω, αλλά μας ακούνε. Δεν ξέρω πώς θα κλείσω το μικρόφωνο. Από εκεί λες.
Io non so quale di questi sarà la presentazione, però
Ποιο είναι. Ποιο είναι.
ma volevo solo vedere.
Te ρωτήσω. Είχε γάμο εδώ πέρα ένα κουμπί που το πάταγα. Ας πούμε τώρα κλείνουμε τα ηχεία μας. Είχε εδώ ένα κουμπί για το μικρόφωνο που το πάταγα και το έκλεινα. Μικρόφωνο. Από τον υπολογιστή λες. Θα σου πω ότι κάνει ευθείας. Αν υπάρχει μισούλα.
Ma tanto ce l'ho io, non scherzavo, ma in realtà in abbondanza. Eccolo. Sì, no, però ve lo scarico comunque dopo perché non so quale di questi. In realtà te lo... Ah, sì, no, esatto. Sì, no,
Siamo. Ci sono quindi anche greci? Non ci sono più tedeschi, quindi? Sì. Good morning to everybody. So now Before Professor Bozzo, there are several aspects that can be tackled concerning the maritime sector. Before, talk about externality. Externality are quite important to evaluation. When we talk about evaluation, is one way to calculate the benefit to use some technology. And if you can, okay. Oh no, okay. So this first slide just show you the what I'm going to introduce. So I will give you just a brief introduction concerning my maritime transportation and important activities, especially regarding to the environmental issue. And as yesterday mentioned in the first day, the commission, DG Move is quite important. Also the legal framework. The legal framework in a way give the general condition in order to achieve
Pronto?
some result. Some problem?
Mi dica. Sì,
Okay.
sì. Cinque.
So go ahead. So just as mentioned before, so the legal framework is quite important. We have some important international regulation like the MARPOL Annex 4. From the European side, the directive of 1932 and the amendment directive 2005 were also define better the two areas, the ECA, NECA, and SECA, that we're going to see deeply after. And then I will just give you a brief introduction concerning the external cost, since also before Professor Bozzo give you already an overview regarding the importance of the external cost, and the main topic will be focused on cold ironing technology. So I made a study, research regarding the feasibility of cold iron technology in Copenhagen Harbor. So I will show all the results, take into account the analysis cost benefit. First of all, I also would like to say hi to the other university that are connected. So I think there will be the Greece University and Jacobs University and the Madrid University. So if they have any question or if you don't understand, for more information, you just press the hand, and after we try to setting up the question. So as mentioned before, the maritime transportation, it's have a strong impact of the environmental market. As you can see in the other PowerPoint, okay. So the estimate SOx and NOx are quite high. Of course, from 2010, 2015, especially the SOx has been cut down due to the regulation. First for the European Commission, and second from the MARPOL Convention. And concerning the MARPOL Convention, just to give you more information about that. So the International Maritime Organization, the IMO, that is a specialized agency under the United States. It's the main body that deal with the safety and the shipping security. And in 1973, the International Maritime Organization adopted the International Convention of the Prevention Pollution from Ships, so as mentioned, MARPOL, and which has been amended by the protocol in 1978 and 1977. That's this in order to keep update for the main topic regarding the SOx and NOx emission. The new MARPOL Annex 4 setting up several limits concerning the sulfur dioxide, the nitrogen oxide, and emission from volatile organic compounds and particulate matter. The MARPOL convention we can divide into main layer. So the one is regarding the sulfur dioxide. Under the MARPOL Annex 4, the sulfur dioxide has been significantly reduced. This also because the sulfur with the NOx is contribute several damage. Like if you're thinking about the major harbor are most of the Mediterranean ports are very close by to the city. You just look Genova, so you can see that most of the inhabitants live very close by the harbor, and this can cause several diseases like respiratory problem and so on. So this is also, if we link as told before, the externality. One externality is also the disease. So what is the price for society? All these emissions. So therefore, first of all, the International Maritime Organization, through the Annex 4 MARPOL and the revised in the 1998, adopt a very strong law in order to cut down and to oblige the state, of course, in different. We can see later is no an homogeneous approach. So there are different areas that gradually adopt some restriction in order to be in 2020 a common area where we can see later the emission will be controlled in the same way. This is just concerning the sulfur. This table show you what is the deadline and what the MARPOL achieved. So you can see that from 2012 for outside for the ECA and inside of the ECA we have different limit. But the most important right now is also the 1st January 2015, and so the limit of 0.1 of sulfur. This is established for the Baltic and North country, and instead for the rest of the ECA. That we're going to see after what is the ECA area, and will be 0.5 from 2020. So also in the Mediterranean area, this will be the new regulation. The emission control area. This map show how the existing and potential emission control area in the worldwide. You can see it's quite it's a huge area, and the ECA in general cover the different emissions, so the NOx, SOx, or PM in different way. This is regarding the sulfur control area, SECAS. And from the Baltic Sea is come to force from May 2015, and in the English Channel 2007. But the most important things that in a way the North Baltic make more strong the limit and the anticipate the deadline. This, in fact, in 2015, the limit of sulfur will be 0.1%. This is apply for the auxiliary engine as well as the auxiliary boilers. It is all these rules you can find properly in the MARPOL Annex 4. It's a very long, it's a very the huge, I mean, a lot of pages, I think it's like 100, 200 pages of regulation. So this is just a summary, but they give you a picture also. For instance, link what they said yesterday, the DG move now, that a lot of project was financing in the TNT program regarding LNG, scrubber, and cold irons. This because in the Baltic area, they are almost ready to start. So in 2015, compared to the Mediterranean area. So the Commission already setting up several study of feasibility in order to be ready to apply all these rules. For instance, yesterday also they mentioned that the TNT program financing to equipment to vessels with the LNG. They already financing study feasibility concerning the scrubber and as well as the cold iron. This because the North area and the Baltic area in few years they have to deal with this limit of sulfur. The other this charter, this table show the schematic representation of the SOx reduction, and you can see from SECA SOx extra from 2015 for the Baltic area become strictly, and the global is bit different from 2020. All the country in the ECA has to achieve this limit. Concerning the sulfur emission. This is the other I cut some the other area from the ECA. You can see the deadline that are planned. This also much with the convention. So you can see that almost apply around 2012. And this is California 2012 too, and Puerto Rico and Virgin Islands. That's quite important to have a worldwide view because after we go a little bit more deeply about some technology like the cold ironing, one of the main problem of the cold ironing is the frequency, because the frequency that the most if you think some cruise ship, the cruise ship, most of it go from USA to Europe, and in Europe the voltage system is 50 hertz, and the major part. Instead in the USA is 60 hertz. So there is also a problem to convert the frequency. And this this has a huge impact on the cost of the infrastructure of the cold ironing. This is just to just give these tips, but after we can, when we go to show the study feasibility of Copenhagen Harbor, we can go more deeply about this issue. These okay, just some few lines that make a summary what I explained before concerning all these areas. So the Baltic Sea area, North American area, and United States Caribbean Sea area. And this is just a regulation timeline for sulfur. and so they give a picture when they start the process in 2013 and plan 2025. So they become more strict, and this also is you need also to deal with different body in order to reach the goal. And of course also the big the more important constraint is the ship owner. All these infrastructure, of course from the port side, but also from the vessels. This is in a way take the decision from the ship owner, because the ship owner has to invest in order to reach this limit. So it has to retrofit the boats. It's a cost, and so the main topic, as usual, is the cost. So the cost is always deal, and but we can see later also this point. Now we skip to the nitrogen oxide, because these are go more quickly because the more technical. So these the MARPOL Annex 6 regulate also the emission of NOx, and they give sorry, these are all the pictures I mentioned before, so you can. This is a timeline. So let's go to the nitrogen oxide. So as I mentioned before, the MARPOL Annex 6 regulate also the emission from large marine diesel engine as defined Tier 1, Tier 2, Tier 3 standards. So the MARPOL setting up a standard requirement with different deadline and with some exception in order to try to reduce also the NOx emission. This table show the emission limit gram NOx on kilowatt hour, and you can see the different timeline. So the tier 1 is started in 2000, and tier 2 2011, and tier 3 2016. So this is the international view. So the MARPOL setting up this limit, but what's also the European Commission, of course, they take into account this emission factor. With the Council Directive 99/32, the European Commission established a limit of the maximum sulfur allowed content gas, and this also in order to be in line with they try to be in line, because in reality there is some time gap between the MARPOL Annex 6 and the European directive. So the directive refers main to the marine fuels, so, and it sets the limit of 1% and 3% for heavy fuel, oil, so HFO, by mass from the 1st January 2003. This is also, I mean, if someone is you want to be more information, they can look the directive article 3 paragraph 2, and 0.1 for gas oil after 2008. At that time, this limit didn't apply to the marine gas using by the ship crossing the frontier between a third country and member state. This directive has been amended in 2005, so that the 2005 is the core of regulation regarding the European country. And the European country established, the directive established an important point. So they oblige to for all the vessels at berths to use a sulfur content maximum 0.1%. So this is the current limits already setting up in the EU ports at berth. So when the boats come in the harbor, so and at berths, so in hoteling, they has to use 0.1 emission of sulfur, or any technology that can achieve this result. So these I just point some bullet concerning the directive. So the ship at berth in EU ports, they has to use 0.1% of fuels, and also the follow the directive try to link what the MARPOL annex say. We have to underline one question, that the MARPOL coming forth for 2015, okay? The European directive coming forth for 2000 and 2010. So there is a gap, because for European harbor they already setting up 0.1% at berth. So we can go ahead, because I prepared some question that can be related to, I mean, to give more clarification concerning the 2005 directive concerning do these requirements apply to all ships? Yes, this directive apply to all the ship, if the EU or non-EU. So this is quite it's quite a boundary. So that's is the first point. At berth, what does it mean at berth? So this covers ships in the EU ports which are secured at anchor or mooring, include a single buoy mooring, or alongside respective or whatever they are working cargo or not. So it's quite also it's quite clear. Does this requirement apply to all ports in your country? The requirement does not apply to port in the outterm region. So there are some regions that are not apply for this requirement, that are the Azores, Madeira, and the Canary, but they are just more detailed issue. So this is what I mentioned before. If they can use, could residual fuel oil be used at berth? In theory, yes. What is important, that this residual fuel not exceeded 0.1%. So this is the main point of the directive. And the last 2 points, that it's required that only gas oil is used at berth. No, because you can use also other technology, for instance, cold ironing, scrubber, the watering in the fuel in order to put down the emission. But what is important, that the result is the same. So the 0.1% of emission. So this is about. The last question is more practical. What penalty could be applied in case there is some vessels that's not compliance with the limitation of 0.1 sulfur at berth? The directive requires that each member shall incorporate into enable legislation a penalty. So this penalty has to be useful in order to be to a way to make the ship owner and ready for adapt or give some solution for adapt the to reach the 0.1 of percent of sulfur. So this is the main point of regulation. So we have one side the MARPOL, the other side the European Convention. There is also the NECA that is that will be introduced probably in 2016, but is still in discussion at the UE level, so international level. So the NECA deal more with the nitrogen. So we have a SECA, sulfur, NECA, nitrogen area, and the ECA will is all the area altogether. So now also take into account what the question that before also come out concerning the subsidy and taxation and whatever. Let's look what other country, I mean, try to setting up in order to achieve this goal. There are two countries, like the Norwegian and also Sweden, make a sort of facility for improve the use of sun technology in order to cut down the emission. So the Norwegian tax NOx taxation is what to say that they create NOx fund that offer subsidy for NOx NOx emission for the ship industry, so especially for the ship industry, so the ship owner. So the first point that all the enterprise are obligated to pay NOx tax in Norway and are eligible to join this environmental agreement. So this enterprise that in a way support to increase the fund may apply for funding to cover some investment and some operating costs. So if we take into account the cold ironing technology, of course you need the technology on the lands, on the ports. So the port has to be able to setting up a sort of infrastructure in order to produce energy, in order to the cable to reach the boats. And from the other side, we need that the vessels has to be retrofitting. So the vessels has to be ready to plug in. So they need the switchboard, for instance. So there are some technology that we're going to see more in the simple way. So just to know what is this cold ironing. And so in this case, the ship owner can, if they are part of this agreement, environmental agreement, can receive some subsidy. The NOx fund subsidy investment with up to 80% of the actual cost. So there is also a sort of a limit. What the tax cover? These are several points that can be studied more deeply. But the tax covered emission from for domestic traffic even if operate outside of Norway. Of course, this is an extract of the Norwegian law that if someone is interested, I can also give to you, because it's a very detailed, and in a way is the first one of the first example of taxation, because we have to take into account the as mentioned before Professor Bozzo, subsidy and taxation are a very hard topic, because you need a common approach in order to avoid distortion of the market. So that is quite important topic. And of course, this annex fund has also some exemption. So they have just put some topics. So direct foreign traffic or fishing, and so there are, it's a very well detailed. The second way of taxation or way to subsidy is the differentiated port dues. So to use the due in order to stimulate, in order to facilitate these technology that are quite expensive. So why the ship owner has to invest money? So I believe that it has to be also a cultural approach, so that's to involve the ship owner in the decision. And these are some example of potential effect of a differentiate port due, and the more things important, the more things that probably will be useful for our study is the example that also Sweden apply. So Sweden as through this system of due in the ports was able to receive fund for some technology like scrubber, or facilitating for cold downing technology, because in Sweden there is already infrastructure for cold downing from 2009, if I don't make mistake. It's related to the roll on, roll off cargo, so vessels, and so they already use also for this technology. And this is more the third point. It's a more theoretical approach. So the voluntary agreement, consortium benchmarking. So this there are different hypotheses. So is no real yet, because some voluntary agreement among the ship owner or the port company in order to, I don't know, choose some taxation, to put some fee on top, to create some fund that can be useful for the infrastructure, for the researcher point of view. So, but it is more a theoretical approach. Okay, so this is the first part that give you the baseline of juridic law, legal framework, what the European Commission setting up with the two directive, European Directive 1999 and in 2000. And the other side there is the MARPOL that also oblige to setting up some technology, some policy in order to reach these limit. So just to make a little summary. In one side we have the MARPOL that set up a different deadline. So from 2015 is the one most close by. So the Nordic and Baltic area has to apply in order to reach the 0.1% of sulfur emission. And from the other side, we have the EU Directive 2005 that obliged to, from 2010, to use oil fuel or technology that reach the point of 0.1 sulfur at berth, not in navigation, but at berth. So the vessels, when arriving in the harbor, and is the anchor and the berth to reach such a limit. This is just some summary what I before mentioned, and of course all these presentation will be uploaded on the website. And if you have any other question concerning these regulation, please welcome. Before to start the second section is more related to the external cost and to the studies cases of cold darroning in Copenhagen Harbor. If there are any question regarding the emission, the sulfur. Yeah.
Doesn't respect the regulation. I mean, for example, in the case of the Norwegian state. So there is an agreement, environment agreement.
Yeah, there are. There are two things that are separate. Norwegian is a bit a special case because it's inside. EU, so it don't follow completely the rules of the division. But first of all, we have to thinking about the division of the area. As I showed before, there are a unique area, so it is a big one. And after inside is divided in the SECA, sulfur emission control, that concerning that North and Baltic area, the limits start from 2015. In case this is a MARPOL, okay? So in case, for instance, one boat doesn't respect this limit, of course, because there are some a sort of tester that can measure all the emission of the boats or vessels. So the member state can decide what will be the penalty that I'm going to do some vessels. For instance, it can be give a time of framework that has to adjust or has to provide, I don't know, or to use the fuel with 0.1% of sulfur that is already in the market. It is quite expensive compared to the heavy fuel, or to adapt the vessels with some technology that can be not cold darroning or whatever, can also some scrubber. So even if the scrubber, they are not so, right now some study, they are not so adapt for for this to reach this limit. So when you and this is about the marble. So if you're thinking about the European Commission, so the Directive 2005, we have already the limit of 0.1 sulfur at birth. So the boats or can use simply the fuel with 0.1% of sulfur content. This is available in the market, or they can use some technology in order to abatement this, in order to reach this limit. Take into account that also all these limits have a common view, no? In order to make a integration among the ports, in order to use more or less, I don't say the same technology, but to reach the same goal. So this is unfortunately, I mean, we have these two way. One is a MARPOL, the one is the European Commission. So they set up different timeline, but just for short.
So it's the European Commission that put the penalization, and the vessel must pay for example, the fee at the European Commission or directly at the harbor in this case, and the Norwegian.
This is the European Commission didn't set up how the penalty has to be done. This will be the national rules, okay, that can decide to or to stop the boats, or to depend what what the national rule setting up. So until now there are very few cases about that. So it's not so common approach, also because despite that the technology is expensive, is available on the market this fuel with the low sulfur. So just the ship owner has just to use the low sulfur fuels at berth, not in the navigation and not in maneuvering. That is completely different. Anyway, there are if you are interested, I can send you the full question answer. Though there are some practical questions also related to this issue. I can also put online, so you can see there are all typical questions that the European Commission, I mean, they're already setting up about that. But it's we have these two parallel, you can say, regulation, so among Europe and MARPOL. Any other question? Okay. Stop. Okay. If we go to, if we can skip in the next slide, we go up and talk about externality, but I try to be more briefly, because Professor Buzz already gave you an overview about what are the externality. So in briefly, the externality is the cost that are not included in the market equilibrium. So if we can keep the next one, this is the supply and demand diagram. So you have the supply, that it's the marginal product cost, and the demand is the marginal price benefit. So in this case, in the equilibrium, you have the optimal quantity that market require. So this is the simple first step. Is quite simple. And what are the marginal costs? The marginal cost is the chance in total cost that arise when the quantity of product change by 1 unit. So it's quite it's quite you can see that in the graphic we have the price and the quantity. So the marginal cost is a curve that you step by step go up, and we assume that the margin revenue is a sort of fix. So the equilibrium is the optimum of market. Is we skip just to give you okay. This is the externality. So as Professor Bozzo mentioned before, is the gap that is not included in the market. So is the gap anyway that everybody will pay or we benefit. We can turn in both way, and this create not equilibrium in the market. This second slide show better what is the dead weight loss of externality, so or welfare loss, and you can see that avanti. Sì, ecco. So you can see that this is the gap. Okay, in this case is this is the marginal cost. Okay, if we add the external cost that the society paid before, we told the external costs are intangible in a way. So you think if you're thinking about the maritime transportation, is the air pollution, so health cost, so hospitalization, so all costs that society paid and they are not included in the optimum of output. So this in the second slide you can see that this is the area with that way lost, and you can see that also that this including if you include the external cost, the social optimum output change is less. So we have a new equilibrium, okay, but this has to be paid or has to be benefited from someone. And this slide, if you come back to the tax revenue, can be this gap of external cost can be used to I should say in order to obtain the equilibrium, we can introduce some taxation in order to keep this amount again. So of course it's more, we can go more deeply about these external costs with also calculation, but I want to just give you some input, and of course if you want more detail we can discuss later, because I think the most interesting part is the studies cases. So once you saw what are the regulation, legal framework, what are the externality, we can apply all these instruments in order to calculate and evaluate the analysis cost benefit, in this case of using cold ironing technology. So this is just the graph. Okay. There any question concerning the externality, something is not clear, so we can skip to the next chapter. That it's a link what we said before. So in order to accomplish all these rules, regulation, in the last 10 years, they are developed several technology in order to cut down the emission. We have a scrubber, we have water in the fuel, so other technology. But what I'm going to focus is the cold ironing technology in the cruise ship. So what is the cold ironing? In briefly, here you have a system description. So you can, I don't know if you can see, but it's divided in different sections with a different number. And so each number is a component. The number 1 is a local substation transformer that transforms from 100 kilowatt electricity supply by national grid. But we have the section 2, this one, is all the cable delivers. So because when the boats arrive in the harbor at berths and anchor, you need also some cable that to be rolled in order to plug to the switchboard of the vessels. So these are the cable that I use. So you have to imagine that the harbor has to be setting up infrastructure. The infrastructure need several pieces. So one is the transformer. Okay. The second is the cable delivery. If you go to the third section, this one, this is useful in order to transform, because as I mentioned before, most vessels will require 60 hertz power supply. It is especially in Italy, in Europe, most port uses still 50 more ports. I mean, the 50 hertz. So this is the one of trick also for cold ironing. So if we skip the technology, we can go more deeply about the why to use the cold ironing technology. The advantages are, one, because they can really cut down the emission. If you think about that with the cold ironing, almost you cut down 90-80% NOx, SOx, and also the CO2 is around 30%. So you are able to cut down a lot the emission, because when the boat are in the harbor, switch off the engine, okay, the alternative engine, and you with the system you plug the electricity. In this case, the vessels doesn't use anymore the fuel, so they reach the requirement, because you cut down a lot of the emission from SOx, NOx. So this it's a good best practice in order to achieve the limits of the EU requirement. Of course, also the noise and the vibration of the auxiliary engine with this system are cut down, more or less eliminated. There are also benefits for people that working in the cruise ship personnel, because if you're thinking about also the the personnel and workers that working in environmental with the emission of sulfur. In this way, it's cut down, so it's also healthy for the personnel. And there are also in some cases cruise ship labor cost to produce energy can be cheaper than to buy the fuel. This is also a very hard topic, because it's important to estimate the cost analysis benefit. So how much does it cost to produce energy? How much does it cost to buy a fuel with a low sulfur? Okay, so this is what I'm going to show you if it's feasible. I mean, when I make the analysis cost benefit, I take into account the cost of the infrastructure. How much does it cost? It's quite expensive, so more than 70 million euro. We can go deeply about that. And how many here I need to have the payback of the infrastructure, or there are any other system that can help me in order to reach this goal. And for the other hand, I also to consider the cost of the fuel. Okay, how much does it cost the fuel? How much is the benefit if I use electricity? And if there are some policy that allow me to cut down the cost of electricity, we can see there are some. There is a European directive that allow to the ports to receive energy with a low price if they are used for clean energy. So in this case, cold ironing. So this is the advantage of the cold ironing. These advantages, as I told before, the electricity power a limitation can be generally cheaper than fuel, but there are a lot of exceptions in that. You can see better here probably. And first of all, is the main advantage is the capital cost invested. It's quite higher for both sides, for harbor facility and also for retrofitting boats. So just to give you some number, for retrofitting boats, it's cost around 1.5 million euro, without including the maintenance. So, and also for the other side, from the infrastructure, more or less is around 30 million euro. Depend how much you want to strong the infrastructure. So the capital cost is quite higher. There are also the other limit that's the other limit that there are few cruise vessels that are equipped with cold iron technology, and 90% of these one that are equipped are using 60 hertz frequency. So the opposite of the European standard at 50 hertz. So we need to spend money and capital in order to convert these frequency. And the other limitation, of course, if you go to the port and you can have just a limited number of key that are able to receive cold ironing. You cannot have 10 or 20 because it's very expensive. For instance, Copenhagen Harbor plan to have three place for cruise vessels that are equipped with cold iron technology. So if it's very difficult also to have a payback This is just a short example what they call iron retrofitting. This is the where in the red line is where the switchboard will be set up. So the switchboard is allowed to plug the electricity. And as I mentioned before, to take into account the data from several studies to keep the vessels as cold ironing. So retrofitting costs 0.1 up to 1.5 million euro. And for a ship owner, it's a quite an investment. As I mentioned before, Professor Bozzo, if you're thinking about that, not all the ports, European port, has this technology. For the ship owner, is not so convenient. So I mean, why, for instance, if I go to La Spezia, there is the cold ironing, the other port. So you need also a homogeneous approach and a pool of ports that join this technology. So this I give you some number. This is the cruise, the current cold ironing market share, and the cruise industry. So you can see that there is a passenger that was estimated in 2012. And you can see that a big percentage is Mediterranean, is 35%. So this is show how the cruise market is quite important. No? That's this is just some number. So this you have the cruise ship during the summer season 2012 with the cold iron capability. So you can see that there are in 2012, for instance, in Copenhagen Harbor. So all summer season that go from May to October, just 6 boats came with cold iron capacity. So it's not a huge number about that. And the second charter table, you can see the cold iron installation in different areas. So how many vessels, and also the number of passengers and the tonnage. Gross tonnage. So they give you an overview. For instance, in Alaska there are 11 vessels equipped, and the Mediterranean 5. So this is quite important when I'm going to show the analysis cost benefit of the cold ironing. Now we go to more deeply in the studies cases. As I mentioned before, the studies case has been made in Copenhagen port, taking into account the cruise ship vessels. So this was a quite narrow subject, and let's see the feasibility of to put the cold iron technology. This chart show how the growth of cruise vessels traffic and cruise passenger in Copenhagen. You can see that in the last year, the passenger reached almost 850 passenger, and the cruise ship 375. So it's became one of the major Nordic harbor. This is the second figure, just show you how is the setting up of the Copenhagen harbor, and they will we create a new quay where we be planning to put 3 berths of cold ironing. It's not yet setting up okay? But it was I made this studies case to see how is feasible to put cold ironing in Copenhagen, okay? So this is just to give an overview about the cruise ship trading and the Harbor Copenhagen. Just some key parameters concerning the Copenhagen port. So it's also Copenhagen port is inside several ports that are important for the Nordic area, and this is more or less is what I already said, no, about the number of cruise ship, the traffic flow, but I would like to skip a little bit this slide and go more in the study, economical study. This is the average of the cruise ship size, and okay, just okay. This is quite interesting. This is the call to port in Copenhagen gross tonnage. You can see how the total calls per year. And now we go to the studies cases. As I mentioned before, so we have the Copenhagen Port Authority study the possibility to have the cold iron technology. So I made this study feasibility, taking into account first of all two main aspects. Okay, that there are three places for berth. The studies focus only to cruise ship vessels, and I assume that there are the energy consumption for each vessel is 10 megawatt, and the average of stay in the quay is 10 hours. Okay, so after that I just make a survey. How much does it cost, the electricity? Okay. The market price of the electricity is 0.15 euro per kilowatt hour. So this is the time that assume per key, so 10 hours. The energy need 10 megawatt, and the average per call per year. Okay, 10 call per year. So 10 call per 10 hour with the price. If the total saving cost per year using cold ironing is 153,000 euro. This if I use the current price. But following the Directive 2003/96, as gave also in another state like Germany and Sweden, you can ask an exemption for the electricity if they are used for clean environment. So if we apply the same methodology, assume that the cost of electricity will be less, so 0.08 per 10 hour, 10 megawatt, 10 call per year, and the total saving cost is 80,000 euro. So the second one is more optimistic, because in a way the electricity costs less, and per year I will spend 8,000 euro. Take into account this assumption. This is just an assumption study. So after that, I assume that for retrofitting vessels into cold ironing, the capital cost is 750,000 euro. So I said, okay, how many here I need in order to achieve this payback? So the total cost per year are more or less 70,000 euro. Per 2 year is double, and so on. So you can see that the annual saving electricity supply, it's not so advantageous. Okay, you need lot time in order to have the payback of the infrastructure from the shipping. So this is quite important also for the ship owner, to see how many years I need to have payback. So what I try to find the positive aspect, that okay, the cold ironing from the point of the ship owner point of view would be useful if several part of the Baltic area join this cold iron technology, because in this way can be more convenient for the ship owner to capitalize the spend. And so this would be the win-win situation also for the environmental point of view. So this is what I'm said before about some number. Okay. So now we go to the last part, and in my study I was also assumed that 70% of vessels visit Copenhagen using shore power technology. In this table, you can see in the first row, if the vessels that arrive in 2012 doesn't use cold ironing energy, this is tons of SOx, NOx, particulate and CO2 that are produced. So it's quite a lot. Okay. So the second, this is the real situation until now, because there is not cold ironing technology. So last year, taking into account my assumption, the emission of SOx, NOx, PM were there. Okay. So after I assume that 60% of vessels were equipped with the cold ironing, and you can see that the cut down it's quite a lot, because you jump from 1.5, 6.1, and 0.6. Okay, with the 70% of cold ironing, and the remaining 40%, I assume that use normal engine, auxiliary engine, because what I mentioned before, we have only three berths. It's not realistic to say that 100% of vessels will be equipped on cold ironing. Also because when we talk about the cruise ship vessels, there are also little cruise ship vessels. They are not only Costa or MSC. So it's quite unrealistic to assume that all the boats are in cold ironing technology. So I just make an average and an assumption. So the total difference in percentage, you can see that using this mix of 60% of cold ironing vessels, vessels equipped with cold ironing, and the remaining 40% with normal auxiliary engine, the percentage of reduction of SO2 is almost 40%, 60% NOx, particulate matter 55%, and CO2 20%. So from the point of the environmental view, it's quite it's useful, because you cut down the emission, you cut down the externality. But if I am going to ask from the point of the harbor, to see if this is feasible, because the cost is quite higher. This is just show what I has been told before. And we can jump to the other point. It's quite interesting. The external health cost per passenger. As I mentioned before, the externality costs can play important roles in these feasibility study, because you can show how much is the pollution, and through the index how much is the health cost. Okay, so there is a study made from the Aarhus University that calculate how much is the health cost euro per kilo of emission. Okay, so if you go to the cost per passenger, if I assume that the electricity consumption for each passenger is 3 kilowatt hour, and for instance, I'm taking one example, cruise vessels. Probably is not so clear because it's very little. In a way, in these two pictures, this is a Baltic cruise Nord that touch Copenhagen. So it's on the north country, and this cruise holiday take long 8 days, and this 8 days almost 37 hours the vessel stay in the ports, and more or less 120 hours in the in navigation. Okay, so this is quite important to because what I need for calculate the external cost is how much long stay the vessels in the ports. Okay, because there I can use the cold iron technology. This is just a graphic that show what I told before is the cost, the kilowatt per passenger. Okay, and this after the calculation that I made, they came out that the total external cost per passenger is almost €2.30. Okay, so if the passenger has to pay the externality, in this case, they have to add on top €2.30. You can see it's not a big price, but in this case can in one way pay the society cost. Okay, that's the individual pollute with the cruise ship. Okay, so if we go ahead with analysis cost benefit, so we continue with the Copenhagen ports, and with the assumption that I told before, so cruise ship vessels, 10 hours per call, and 10 megawatt of energy consumption. For a socio-economic perspective, the capital cost that has been estimated from the Copenhagen harbor, more or less 35 million euro for harbor facility, will be recovering in 10-15 years. Okay, now we're going to see more deeply this stuff, this last part. In this slide, you can see is a feasibility cost. But they give you some number. How much does it cost to retrofit to make the infrastructure in the harbor for cold ironing? So the cost will rise around 35 million euros. So if the harbor wants set up the cold ironing technology, has to invest 35-6 million euro. Okay, it's quite a lot. So how you can make feasible this cost, we can work on the external cost point of view, because we can say that if these are all the this table show you here is the cost of a shore power utility, okay, 36 million euro. In the other side is the total reduction emission per season. So if I use cold ironing, as I showed before, 60% cold ironing, 40% with the auxiliary engine, I saving in tons per season, 2.5 tons SOx, 250 NOx, and so on. This is saving pollution, we can say, okay. So what I did is that I take into account these the study that I mentioned before. The study was focused on Denmark, concerning the health cost, and there was and there is a parameter in order to calculate the externality, okay, per kilogram. You can see that probably it's too little, but here they say that for instance, 2011, what I took, the SOx was is calculated at 17.2 euro per kilogram. Okay, so I have tons here. I convert the tons in kilogram and I multiply. I will obtain the external cost. So how much I will saving using cold ironing technology in external cost. This is the price. So per year, the total cost is around 3 million euro. Okay, so if I use cold ironing for 60% of vessels, and so I will have a benefit of emission. This is a gap of the emission. How much is in externality cost? So how much is the saving cost to use cold ironing technology? Per year is more or less 3 million euro. When I say externality cost, I refer to health cost, because this study show that, for instance, the habitant close by of city, they have problem with respiratory problem, cancer problem, and so on. So there was, of course, this is a cost for the society. So if I will able to cut down these or reduce this emission, in a way, I also reduce the external cost. So it's a benefit. So when I present this study to the Copenhagen port, this was the hang to a way to obtain the green card or so on from the political point of view, because as I mentioned before, if you look on the cost benefit, you need 20 years to have the payback. Okay, but if I include the external cost and say, well, if I use in cold ironing, I will save in per year 3 million euro per year in external cost. So it's a benefit for society. For in 15 years, I will reach 45 million euro. Okay, so I will repay the infrastructure, because infrastructure costs around 35 million, and in a way I repay the costs back. But in the other hand, also I cut down the externality, so some are costs that society pay. So this is was the end of my the study that I make in Copenhagen Harbor. So they show that the benefit of cold ironing, and from the other end also the limit. The limit is the cost, But just for make a conclusion, the system can work better if there are more harbor that using cold ironing technology, because they can make a pool, and one way can be convenient for the ship owner, and the other end can be also convenient for the port facility. Okay, so this is a hard topic. But I'm quite positive if you look from the health cost point of view, because you cut down a sort of emission. This was just studies cases that I conducted in last year, so it's quite new. And of course, in Copenhagen it is not already established, but just was a studies of feasibility in order to see if it's feasible to use this cold ironing. So this is the main analysis. There are any questions or more clarification, because I skipped some part, so I'm more than welcome.
Interesting to know who and how should be paid the benefit that the cold ironing technology can provide at the port.
I mean, this is, I mean, who be paid? I mean, of course, if you take, I mean, let's make a step back. The cold ironing technology is already used in the market, for instance, for ro-ro vessels, so ferry boats. Why? Because it's more easy, because the ferry boats used to do very regular routes, roll on, roll off, and so doesn't have the problem of frequency. For instance, if you're thinking about the cruise ship, there are cruise ships that go from USA and make several stops in Europe, so there is a problem from frequency, and as I showed before in the slide, it's quite expensive to set up from technological point of view, the converter. Okay, the cost of a cold iron, of course, is a major investment from the ports. So it's the ports that establish inside a green policy to have several technology in order to one way to reach the limit of EU regulation, because at one point, or if like or don't like, you have to apply with the limit. Okay, and of course there are also funding. I mean, there are funding from EU projects. So, but the main aspect is that is the port has to financing the infrastructure. What I try to explain to my study that okay, the infrastructure facility is the big point. It's a big obstacle. Okay, because it's costs money. But for the other side, there is a positive benefit, because you cut down the externality. So in one way, you can the society can benefit, but the cost is still on the. If you talk about the harbor, is still on. I mean, on top of the ports, the government, so at the national level. Instead, for the retrofitting the boats, there is a cost for ship owner. There can be, for instance, some case in, I don't know, some port, in order to stimulate the ship owner to adopt the cold iron vessels, to give, I don't know, the switchboard, so they pay some infrastructure in order to make more attractive the cold ironing, because it's a cost also from the ship owner. But all this technology, if you're thinking also about LNG, the cost is the still the big strength. Okay, so but we have from above to there is the regulation that go step by step more strictly, and the other side there is also environmental problem. So the cost is on the arm. Of course, we can, as I mentioned before, there are Norwegian found. There are some examples that can be taken into account, but this is just solution that can be feasible or not. So it's the most concerning the cost is the big gap. It's okay. It's clear.
Yes, it's clear, but I didn't get how. I didn't get how you can receive the money from the benefit that you do for the environment.
Okay,
I mean,
so
in
the
the final
cost.
in the final in the conclusion that you did,
Yeah,
you told that you have, if you invest in that technology,
yeah,
you can receive 3 million 4 years, more or less. I don't remember.
Yeah.
But who must pay at the vessel or at the authority port that make infrastructure this money?
Well, there are two questions linked, but they follow different path. One is external cost, so it's something that it's virtual. Okay, it's some things that create the distortion in the market if we don't consider social for the social. Okay, and the cost that I showed 3 million euro per year is the benefit from the collective if we use the in this case cold down technology benefit because you one way you cut down the emission, and as I mentioned before, the emission are also cause the disease, respiratory problem, hospitalization, and this is a cost for society. Okay, so if I cut down, the benefit is for the society, of course. So there is no physical money that go to the port authority or whatever they establish Coldari. But in approach, a global approach, when you make a policy decision, if it's a government, it also to take into account the different issue. But if you're talking about cost, as I mentioned before, is not feasible from the cost point of view, because you need at least 30 years to have the payback, without including the rate market, so the interest market, because of course you have to borrow the money at the bank. So there is it's quite it's quite tricky, but the cost, if you be thinking about to the marketing oriented, is not feasible. But this technology as the other, they can cut down the emissions or the externality. So this is but there is no physical way to pay. Of course, we can establish that, as I mentioned before, no, the passenger can pay. So in the end, will be the passenger, as usual, to pay the externality. So on top of the ticket of the travel, they have these I should say fee, but it's not fee, that contribution from external cost. So, but this is just relative for the trip that I take into account. So as was related to not the investment from the harbor, but for the ship owner, so the retrofitting of the boats. So I hope that's is more clear. But if you like, later we can I can also give you more all the study about that. Because due to the time, I just I put on the table the main topic. There are other questions from the other university? If there are another question, we can take a break and we can also talk later. Thank you very much.